I'm Mike Driscoll. I'm a principal and founder at Dataspora LLC. We're a business analytics consultancy here in San Francisco. Our goal is essentially to help businesses that don't have in-house analytics teams make sense of their data. My own background actually is in the life sciences. I did a doctorate in bioinformatics, and that's really where I got exposed to big data in the genomics world. And what I'm trying to do here now with Dataspora is take some of the tools that I've learned in the genomic space and apply them to the wider world of data. And I guess I found myself in a good spot with a growing interest in big data. I think where the real challenge comes is not in data management, but in data analysis. And I think we've seen in the last few months, and increasingly in the last couple of years, a growing interest in analytics. And I guess there's a number of tools out there I think that have kind of emerged onto the scene or gained recent interest because of this. One of them, of course, is things like Hadoop and MapReduce, but also the open source programming language R. And I think one of the key advantages of R, among many things, R is essentially a language that does three things. Number one, it's great for data manipulation. Number two, it's great for statistical analysis. And third, it's great for data visualization. Where I see R having a real impact in the data analytics space is actually in its ability to be embedded onto an open source stack. So just as we had with Linux, Apache, MySQL, and PHP, the classical LAMP stack serve as the fundamental architecture for a lot of web services. I think we'll see R as starting to be embedded into some of this web infrastructure and start to be part of the analytics that a lot of companies use. So the complexity theorist Stuart Kauffman has a great analogy story that he uses to talk about how networks evolve. He talks about, imagine you're sitting on a floor strewn with buttons, and you start to, with about 400 buttons, and you start to connect these buttons together at random, one by one. And the question he asks is, how soon after you start connecting these buttons together, one at a time, getting clusters of 2 and 3, how soon is it that you get a single large cluster that emerges from this group of buttons? And it turns out that this sort of single supercluster of buttons does not emerge gradually over time. It actually emerges suddenly. There's a tipping point around when you go from having many different groups of buttons to all of the buttons being connected together. And I think this is this tipping point in networks, I think, has an analogy to what we're seeing now in the world of data. So in the last few months, we've seen a number of different organizations come out and open up their data sets. We've had the Guardian newspaper in England, the New York Times corpus. Amazon recently came out with their public data sets initiative. Google just yesterday announced that it was releasing and putting online a lot of data from the Bureau of Labor Statistics and other government agencies. I think what we're seeing is a movement of people putting data out there that can be connected to other data sets. And I think we're approaching a tipping point in the world of data, and I think that's a very exciting thing. The question is, what happens next? There aren't a lot of tools, I think, that exist right now for making sense of this world of big data. People are trying, but for now we've actually lived in a world where most data lives inside of companies, inside of firms, organizations, institutions, in data silos. And we're just now turning the corner where these information silos are starting to connect to one another in a world of linked data. So I think that's very exciting, and I look forward to witnessing how a number of different data scientists make sense of this data going forward.